So you may find it strange that some people talk about apocalypse is now, right? It's here, it's happening all the time. Unfortunately, the age of decay is here and it's happening all the time. We go through these cycles and we're on a downward cycle for sure. So my car, which very nicely tells me when I have a problem with air pressure, complained about the air pressure the other day. So okay, just drive down the street. We'll go get the air filled. I went to 3 gas stations. None of the air fillers worked, not 0. I tried to go to 2 other gas stations. People were at those air stations. So then I went to another one at the grocery store, and that was taken. And then I went back there. Thing didn't work. They couldn't pay it. And then I went out again and said, oh yeah, the car tells you again. Like, oh, tires are out of air. So I go out again and go to the gas station. Fires right up. $1.25 gone out of my credit card like that. The air check doesn't work. More air out than in. Then I go to the grocery store because that's where I was headed anyway. And it's a little cold out, so I decided, no, we'll deal with the air some other day. I go to the grocery store and she can't check me out correctly. Just trying to buy groceries. Can't be done. Can't be done. Not without a problem. So, the age of decay is here. The age of decay is here. It's getting worse. And I was thinking about, in the midst of all this, I've been playing with some software. My brand new laptop, brand new OS, brand new installation, brand new. Trying to get some Python code to work, and I did. And then I said, well, this has got a GPU. We should get the GPU stuff. I'm doing some AI work, which I haven't touched in a while with good reason. And the computer took 7 hours somehow on literally the world's fastest laptop. This thing is insane. It's insane. It's like a 20 core machine, and it's got 32 gigs of memory, and nothing should take 7 hours on this. This thing should be able to calculate the entire existence of the universe in less than 7 hours. It is a fast computer. Runs for 7 hours and then says, oh, can't do the installs. It's like, what? Takes 7 hours. You're doing a dependency check. It's literally a binary tree. It should take seconds at most to resolve this. Don't know what it's doing. No idea. You could read the whole hard drive on this thing 22 times in 7 hours and still have lunch and dinner. There's nothing should take that long. Literally nothing. And then it sort of occurred to me that one of the problems that we're having is in computers right now, we're not accounting for starting points. So everything is being done relatively, right? Everything's relative now. So you enforce a state in something, and a lot of the configuration tools that run the cloud do this. We want to make sure this is always that, and that's always this, and this is always that. And the problem when you do the relative thing is if the thing you're starting from isn't the same, making relative changes actually has unknown effects. Like there's side effects, unknown side effects. So I think that's what's going on. And the funny part about this is, to some extent, I should have sort of noticed that trend a little bit sooner, because for years in my consulting, people would be like, I've got all these random problems and blah, 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 right? And I go, all right, well, I don't want to deal with those problems. Let me just analyze, because I'm an analyst, among other things, analyze the situation. And then I'd invariably notice configurations weren't the same. And I'd say, all right, let's first just fix all your configurations, right? Boom, 17, 18, 20, 300 problems solved, just like that. They just went away, never appeared, ever again. Didn't have to solve any of those problems. I'm looking literally in one sense, one layer beneath, right, which is the configuration. In another sense, I'm using an abstraction, right? So instead of looking at the specific bugs, 17 bugs, 300 bugs, I'm not joking. These are real numbers, like hundreds of bugs in some of these systems that people would have lists for. Well, here are the bugs. And I'd be like, okay, I'm not going to touch any of those bugs. I'm not going to troubleshoot a single one of them yet. First thing I'm going to do is take a bird's eye view and say, all right, what does the system look like? Right. And then, I'm sure you could have gotten it down to, all the systems of this type, or all the systems that were built in this time frame, or all the systems sitting in a configuration like this have this bug, right? Maybe, right? Or you could just take the bird's eye view, go, the systems aren't consistent. Let's make them consistent first. Bang, all the bugs vanish. And not all the bugs that they had, but a whole class of bugs goes away. So that, again, interesting, right? Like that works. Like that's the thing that can happen. Everything can just magically get fixed, not by looking directly at the thing that's broken, but by looking basically at the overall ecosystem and fixing that, and then problems vanish. And now all of a sudden, a bunch of other things get fixed, right? And then it's easier to fix the remaining things because those are actual bugs that aren't, we'll say, in the environment, because you fix the environment, you've made it regular. And it's this unwillingness to do this lack of doing, and it's very expensive in software to like pause development, right? Stop your developers from working, right? Update all the environments, all right? Put into place release standards and deployment systems and all this stuff. It gets in the way of development, but it makes the quality of software orders of magnitude better overnight. So, if you want quick, that's great. If you want working, well, and if you want high quality working, well, it's a cost you got to pay. And it's everywhere. But it started in software for me. So I saw these things there first, and now it's just everywhere. It's everywhere, which is ironic because software in many ways is non-material, right? Like software it's not a material thing. And yet they treat it like material. And that's what happens. You get relativistic with it. And the next thing you know, because material is transportable, right? Like you take a rock indoors, you take a rock outdoors, the same rock. You can't transport software like that. You can't take a software that runs on your laptop and transport it to the cloud. That won't work. Like that actually will not work, right? And that's the problem. Like we think that the software will be the same, right? You also can't transport software through time. Hence the 7 hours. What it was actually doing was trying to do a solution for all the versions of all the packages that were wrapped up in all the new packages that it wanted to install. And so it's trying to figure out, well, this old version needs to work with this old version, right? Which, it is big, but it's not combinatorial explosive. Actually, if it's done right, now you can always make something in software, anything combinatorially explosive. It's really easy to do. And I think I've talked about this bug before, but reading in a small file that's 100 megabytes and then allocating 8 gigs of memory to process it, obviously we know what the bug is. It's a logarithmic scaled error, right? Over time and over seconds, though, not like over 1 minute, even over like 34 seconds. Bang, you're taking in a tiny amount of data, starting to process it. You're blowing up to 8 gigs. You can't. Like it's, what are you doing? And wasn't obvious, right? The engineers didn't understand what the problem. Like I knew what the problem was. Immediately knew what the problem. There's only one way to get that problem. Actually, there's only one way to get that problem at that scale. You can't anything that increases memory that fast. You know exactly what it is. Because you're processing everything you've already processed over again and adding 1 to it effectively. That's what you're doing. That's what gives you a log scale, right? It's one of the things. It's not the only thing that gives you a log scale. It's one of the ways to get a log scale. But when it's a file, I mean, it's the only way you're going to get a log scale is by duplicating the memory over and over again at log, right? And there might have been other things going on, but log scale is definitely sitting right there in the data. So this problem with software is not just with software. This way of thinking is spread out everywhere, and it's infecting everything, and it's very parasitic. So that's just a pattern that I've seen. That's just a problem. And we're in the age of decay, unfortunately. Software's already there. It's already decayed. Jonathan Blow's a wonderful talk on this and Fall of Civilization. And understated, I would say. I don't think even he understands the scale of the problem that we're in the middle of. And it's often hard to see what we're in the middle of. But yeah, we're in the middle of decay. I don't think things are going to get better. I mean, when you go to the grocery store and they literally can't check you out on a system that's pretty stupid proof at the end of the day, that's not a good sign. It's just not a good sign. So, yeah, it's a big problem. So, yeah, just beware. Age of decay is here, and it's coming. It's coming.